I responded to your email on Island One.
Ah,
Yeah.
I'm,
In
Hi,
terms of the
Werner.
legal, in
Hello.
terms of the legal status, you
mhm,
probably want to have the consortium incorporated in Luxembourg because they have the most advanced space law in Europe.
right.
So that would be if you're going to look for European corporation, it would be under Luxembourg because they're very pro-space, they're pro-space commerce, and they have a good legal structure. So most of your problems, legal problems, would disappear with them.
That's good. And also, if it if that was done rather than it being um, centered in the United States, that would get rid of any anti-US views.
Yes, and there are also a lot of venture capitalists in space and look that work out of Luxembourg because of the communication satellite that's centered there.
Hmm. Okay, good.
Okay, so 4 minutes after 9. Let's wait another minute. If maybe somebody else will join.
I'm perhaps also in Luxembourg.
Oh, are you?
Yes.
Oh, well. We'd look forward to your involvement then.
Okay, a lot of helpers, artificial intelligence tools to help us, poor humans, imperfect humans. Okay, let's start. So, what I would like to talk with you today is the the importance of a couple of papers that I have found doing my doing a research for a presentation that I am preparing. By the way, I can also show you this presentation is maybe 80% complete. And yeah, these two papers are from NASA. And the first one is in 76, and the second one is a couple of years later. And they are both about space settlement. They were both directed by Gerald O'Neill, and they are very, very complete and organic discussion about an O'Neill infrastructure, be it Island One or something else. However, I was really happy to find these documents because let me say the group that composed these documents, they are big documents, 150 pages more or less, started from the human requirements. So not only technical requirements, but also social requirements and all the human dimension. So let me say the same thing that we try to do, and we may do it in a very reduced way with the ethos, with our ethos requirements document. Because in the ethos requirement documents, we have put together scientific, technical, and social and humanistic requirements in general terms. So I'm very happy that these documents exist. They are from the 70s. They are based on the Gerard O'Neill research and studies and on his design of Iceland 1, the rotating cylinder. But then these documents also analyze other shapes, torus, for instance, and a number of torus connected together. So it's a really very, very interesting and complete discussion. So I have added this. Okay, let me share something, because I think it is important that our committees, our two committees that we are joined today, the Space Habitat Committee and the Living in Space Committee, I think we should deepen a little bit the study of these two papers, because I think we have to start making a very biggest campaign in favor of cislunar space. I'm sorry, because I'm also opening a web page. I'm trying to do two things together, and okay, let me do that before. And sharing, share. Okay. So yeah, can you see my desktop? Yes. Okay. So in the
Yes.
in the part of the Space Habitats Committee, I have added in the literature the Space Settlement Design Study NASA SP413 and Space Resources and Space Settlement Design Study NASA SP428. Because yeah, I think it is very, very important and interesting to understand more of these documents. And also, I don't know why I cannot. Okay. So I am sure that some of us already know these documents. For sure, Jerry. Maybe maybe Werner also.
I know it very well, yes. It is
Yes.
called the Stanford Torus.
Yes,
The
exactly.
Stanford Torus.
Exactly.
Looks like a CD.
Yeah, and yeah, by the way, exactly the Lagrangian point L5 is considered the best location to put one of these things in the beginning. And there are detailed calculations about the amount of lunar materials needed and what should be taken from Earth, what from the Moon, etc., etc. And yeah, physical properties of space, solar radiation. So even the issue of protection from the ionizing radiation is discussed. And yeah, it would be worth to read attentive. I have not studied in detail the paper, but I think it would be really interesting to see what they wrote more than 50 years ago about
Yes.
these problems, meteoroids and space habitats and so on. So this is a collection of papers, okay? Each one with its own focus and discussion. human needs in space. Weightlessness, pseudogravity is needed. Atmosphere, less is enough. And food and water, combined environmental stresses, probably not serious. Environmental design to reduce stress. Diversity and variability is talking about human diversities, different ethnical groups and space needs within the colony. And the small size and isolation. Trade is essential. Governance and social order. Summary of design criteria. So physiological criteria, environmental design criteria, and organizational criteria. So these guys were taking very, very seriously the settlement issues, psychological and cultural considerations, the solipsism syndrome in artificial environment, the different types of communities, types of social organization, individualistic and isolationistic, or heterogeneistic, mutualistic and symbiotic, and hierarchical and homogenistic. I think maybe Marie-Louise, in the part that you have developed for the ethos requirements, you were discussing some of these points.
Yes.
I remember.
It's very interesting, yes.
And okay, self-sufficiency of extraterrestrial, international participants, residencies, shops and offices, various community activities, and so on. So I think we maybe could take as a goal of these committees to have a deeper study of this document, and then we can have a discussion later after studying it and taking inspiration, because maybe in some project that we are trying to shape, I'm talking about Island Zero, I'm talking about the Lagrange Space Factory, I'm talking about the ethos habitat for 100 inhabitants. We can improve something and add something after having studied these documents.
And I think we also can show the difference between these older papers and nowadays standard.
Yes. By the way, the reason why I am preparing a presentation is because I have to hold a lecture for students in April, students at University Federico II of Napoli. And the title of my presentation will be "Why to Build an Habitat in L5? Why in L5 and not on the moon?" So I am preparing a presentation that if you want, I can show it to you as it is now. It's not complete, but it is almost complete.
Is it one
Is it in
presentation?
Italian? Is it in Italian, Adriano?
No. I am making it in English because
Okay.
there will be no problems to present slides in English to students and to talk in Italian. So it's because they are used to see.
Is it one presentation or more presentations?
No, it is one by now.
One, okay.
But
Do you know whether there are objects, other objects now in L5?
No,
I think no, it's empty.
Maybe
yes.
there are some asteroids, maybe some small asteroids in the Lagrangian points, which have been caught in the last millennia or something like this.
Okay.
But we have not put anything there. L5 and L4 are at the same distance as the moon, but 60 degrees in front and 60 degrees
Yes,
behind it.
exactly.
And
So
to go back to the question of why there, this all comes back to a question that Gerard O'Neill put to a new class of students back in 1969. The question was, is a planetary surface the right place for an expanding technological civilization? And the answer seemed obvious. Yes, you go on the moon or Mars or something. But the students went away, and the results of their research was that the answer was no, because on any planetary surface, you lose the sun for 50% of the time. And particularly on the moon, where the night lasts for 2 weeks at a time, you have got to provide all the power during that time. Whereas they said out in free space, you get the sun's power all the time. You can turn it into
yes,
electricity, and you can concentrate it to get 5,000 degrees to process materials. And that's what all of this came out from.
Yes, and I think there is another reason, because most of the small planets, like Mars and so on, have less gravity than Earth has. Only
Yes.
Venus has the same gravity, but it is much more hot than Earth is.
yes,
It's not a place to go to for your
Not a
holidays.
place to go to for
And
humans.
the other thing is, when you land on Venus, you need almost the same energy that you will need to take off from Earth to return. Whereas in something out in free space, you can simulate gravity for the inhabitants, but you can have your spacecraft in a weightless condition, and they're just simply in lunar orbit. Much easier to travel around.
Yeah.
yeah. Okay, so let me show you my few slides so I can also take profit from your comments and suggestions. So this is the overview, living and working in the geolunar space, two alternative models, Selenopolis, the Kraft-Erike model, and Iceland 1, the Gerald O'Neill model. As I will say, they are not really alternative because the Erike model is good for working on the moon, and the O'Neill model is good for living, for
Exactly. Exactly.
So, but however, yeah. So here I will give a little bit showing the differences between the Erike model about Selenopolis and the Gerald O'Neill concept of rotating cylinder. And
No, sorry, I have to stop you there. Gerard O'Neill did design large cylinders. That's the Island 3 model. And those are 4 miles in diameter, 20 miles long. Island 1 is a spherical habitat, a Bernal sphere.
yeah, the Bernal, yes, yes, exactly. Okay, so
Yeah.
you have to maybe to correct a little bit this thing.
You just say spherical habitat rather than
Yeah,
cylinder.
yeah, yeah.
That's okay.
Yeah, but because Iceland 1 is not a cylinder, but it is a sphere. It is the
Oh,
Bernal sphere. Okay,
yes.
okay. Let me take a note. Okay. Then, okay. Who are these two geniuses, Kraft-Erike member of Werner von Braun team at NASA, propulsion engineer, space philosopher, and he wrote Extraterrestrial Imperative is his main conceptual papers, let me say. And Gerard O'Neill, Princeton University teachers, he founded the Space Studies Institute, and he wrote the High Frontier Human Colonies in Space. These are his main works. And okay, so a little bit of explanation of the Selenopolis, a plant for lunar industrialization or birth of a polyglobal civilization, as Eric named it. He conceived the plan in 5 plans and 5 steps. And if, as you can see, it's all about industrialization, and only in the last one, in the step 5, it thought about the city, self-sustained lunar city founded on powerful fusion energy base. Lunar products is worth to have a listing of the lunar products, and so what it can be extracted from the moon and then processed, and not only processed on the moon surface, but also in a circumlunar orbit facility that is probably in a Lagrange point or in a lunar orbit. Okay, lunar industrialization. The vision of Eric included the moon and surrounding space region, Lagrange points. This is lunar space. The main industrial processes to be placed on the moon surface, like raw materials extraction and processing, energy supply by nuclear plants, and here I will also mention the Selene project that is done by Enea. It is the Italian entity for the nuclear power. And we also had a webinar recently, a lecture by Andrea Lani, that is the director of this project. Orbital industrial facility taking profit of zero-G, Earth, Moon, quick and low-cost transport systems, and so on. Now, the O'Neill model, starting from the famous question that he made to his students at Princeton University in '69, is a planetary surface the right place for an expanding technological civilization? And the students replied no, because the planetary surface in the solar system do not have the same gravity of Earth, because migrants to the moon and Mars will experience dramatic biological and physiological changes in a few years. Earth may suffer heavy damages. They could go back to Earth only in a wheelchair, and that's a heavy limitation to freedom. Gerard O'Neill conceptualized a big rotating habitat for thousands or even millions of inhabitants to be placed at an Earth-Moon Lagrangian point in the '70s. So there are different of mission requirements. There are three classes of mission scopes: space exploration, scientific research, and space settlement. As far as a space settlement is concerned, the living systems, including humans, requirements need higher relevance and priority. Contrasting effects of zero or reduced gravity, protecting life and health from ionizing space radiation, providing an environment similar to the Earth's environment, including flora and fauna. Also, on this point, the NASA documents are very detailed detailed and accurate, and it is really astonishing why NASA seems to have, I don't know if forgotten these studies, or they don't give the priority that they should have in their program. So this is a picture from the Expanse, the James Corey work and the TV series that was derived from it. We see a belter, a human that was grown on the asteroids, and here this poor guy is on Earth, and it is constrained to stand up in the high gravity of Earth because they wanted some information from him. So it's a very bad action what you see here, something like a torture. And however, yeah, the physiologic changes are elongated bonds due to low gravity conditions with respect to the Earth.
And they become giants. They become giants on Mars, for example.
Yes, exactly. And yeah, while living in L5 is better than on the moon, gravity lower than 1G will cause heavy changes to human physiology. Lunar, Martians, Belters, Ganymedians, etc. will become not only new ethnic groups, likely they might be defined as a new variants of the human genetic strain, as sapiens and Neanderthal. Likely humans will adapt, think about the differences between Equatorians and Eskimo. Yet too fast changes and adaptations will generate heavy problems, three main orders at least: biology, health, reproduction, freedom of movement and migration, social problems due to the diversity. Think about skin colors on Earth, what difference in skin colors produced in terms of racism and social problems. Okay, NASA in 76 develops a study on space habitats. 2 years before, ONA published his paper on space colonies. And in 76, NASA published a comprehensive design study on space habitat. I am, okay, in my lecture, I will put the accent on these papers because I will propose to the students to study these papers and maybe take inspiration for their graduation work. I will say to the students, look, these papers are una miniera, a mine of concepts that you can take and maybe develop for your graduation work, imagining the implementation using the technologies of today, using reusable launchers and everything, and artificial intelligence and everything what we have today. That in the 70s, of course, they were only science fiction. Human requirements according to NASA: weightlessness, pseudogravity is needed, atmosphere, food and water, combined environmental stresses, environmental design to reduce stress, small size and isolation, psychological and cultural consideration, space requirements of various activities, residences, schools and hospital assembly, etc. Design criteria, physiological criteria, environment design criteria, organizational criteria. And the people, requirements by people, size and suitability of population, ethnic and national composition, age and sex distributions, export workers, social organization and governance, and life support, food, recycling, waste, composition and control of the atmosphere, etc., light and dark, comfort, ergonomics, beautiness. Here, are different possible shapes of the habitats: the sphere, the torus, the several torus combined together, and beaded torus. Shielding by active shields and passive shields, magnetic shield around the torus. So this concept of magnetic field is very interesting, and yeah, also on this on this argument, we had a lecture recently about a shield for re-entry protection, thermal protection during the re-entry in atmosphere, a magnetic shield. That was very interesting too. And okay, passive shields. I still have to implement a slide on passive shields. Okay, main references I already said. Then where in free space at L5 or L4, the colony could be located in any one of the number of orbits in free space around the Earth, on the Moon, or both Earth and the Moon. But near either Earth and Moon are not suitable because of the frequency and duration of solar eclipses, which deprive the colony of its light and energy. Large orbits around the Earth make it difficult to deliver the large mass of material needed from the Moon. The remaining orbits about the 5 Lagrange libration points, L1, L2, and L3, are known to be unstable. To maintain orbits around any of these points for a long time requires appreciable expenditure of mass and energy for station keeping. There do exist, however, large orbits around both of the remaining libration points L4 and L5. These have been shown to be stable. A colony in either of these orbits would be reasonably accessible from both Earth and Moon. We might arbitrarily choose L5 for the location of the first space colony, through the differences between L4 and L5 are very slight. Okay, here is a representation of the Lagrange points. The distance L1 is about 5/6 of the Earth-Moon distance. L2 is in front of the far side of the Moon. L3 directly opposite to the Moon. And at 60 degrees from Earth-Moon axis, L4 and L5. 4 and L5. And okay, characteristics of Lagrange libration points. On the Earth-Moon axis, they are comparable to eels. Objects placed on top tend to fall off. They are unstable and require correction of attitude. They can, however, be placed in orbit around the point. The objects, artificial object, can be placed in orbit around the point. At 60 degrees from the Earth-Moon axis, they are comparable to valleys. Objects placed in the valley tend to fall to the center of the valley. They are stable and do not require attitude correction. They can also be placed in orbit around the point, of course. So now, rediscussing Erike and O'Neill, two insufficient models. The Erike solution might solve the problem of cosmic radiation protection building selenopods in the lunar subsurface. But there remains the problem of the Moon's gravity, which is 1/6 that of Earth. Fatal for the inhabitants that, once addicted to the lower gravity, would suffer inevitable physiological mutations. O'Neill's solution, on the other hand, would solve the problem of gravity, but how to shield the large structures the size of the magnitude of kilometers from cosmic radiations. Solving both issues could be a solution for both problems could be using near-Earth asteroids. Some of them, like Apophis, have a low delta V. They could be captured and taken, for example, in L5, NASA. The asteroid could be dug inside, obtaining an enormous spheroidal space. Resulting materials may be used to construct dwellings and all urban, industrial, and agricultural infrastructures for settlement by thousands or millions of people. The complex may be imprinted rotation to generate simulated gravity. Several meters of rock would interpose between the habitat and the outer space, protecting against radiations and micrometeorites. Then okay, this part is not completed. I am making several hypotheses. This is Apophis. And all of these concepts are taken from our paper Asteropolis that I conceived it and then we improved it.
That
By
was
the way, this
yeah, that
option was also discussed by Gerard O'Neill in his late studies using an asteroid. I
it was
didn't.
also covered extensively in a book in 1964 by Dan Rich Cole called Islands in Space, which is a very good book you should look up. He discussed the idea of howling out asteroids back in 64, and so does Asimov in 67. So that's been around for a long time. And there's some good arguments for it.
Yes, yes. This is a forerunner, let me say. So before or contemporary to Gerard O'Neill studies. Yes, it's interesting. Three candidate asteroids are Apophis, that is a small one, let me say. And then 2005 YU 55, three times as massive as Apophis, approached Earth, Venus, and Mars. Multiple possibilities for gravity assists. Approaches about every 11 years with relatively close approaches. Possibility of incremental approach every 100 years for every 11 years. For instance, the first time we go there and see what we can do after and maybe start doing something and see how the environment react. Then after 11 years, we might maybe after 11 years we could have already been experimented on Apophis, the smaller size. So we will be maybe ready to start working on 2005 YU 55 and maybe to redirect it to the cislunar space. And yeah, 11 years later, we can do other things and so on. And the biggest one is 1999 AN10. This is 5 times Apophis dimension. It is a fast and dangerous asteroid passing as close as the moon in 2027. It is large enough to house 2 million people in a 3-kilometer diameter habitat. Hard to capture might be worth after experience with smaller ones. Okay, so this is what I have done so far. I still have to implement maybe 10 more slides, and then I will be ready to contaminate those poor guys, poor boys.
It's a very good work. It's a very good work, Adriano. If we have enough time, I could present you my last work. I have started a new project about Mars, about a concept for a rotating space habitat around Mars.
Oh,
if
wow.
we have enough time, yeah, I can
Why not?
show it to you. Yeah, yes. Okay, I will try to share my screen. This is that's the wrong one. Wait a minute. Okay. Okay, you can see it. I think so.
Yes.
Okay. As Mars is a planet
Yes,
which has just about 38% of the Earth's gravity, I think just a few people should land on Mars and live there for some months or years. And the alternative would be to build a Mars habitat inside one of the Martian moons, for example, the Martian moon Deimos, which is the smaller one. And we could build a human outpost with 1g simulated gravity inside this moon.
Mm-hmm.
So you see this Martian moon Deimos. It has about 15 kilometers and 12 kilometer and a mass of about 1.8 trillion tons and a bulk density of 1.47 grams per cubic centimeter. So this is the shape of Deimos. It is from NASA. It is a NASA picture. So it is a relatively small moon, which has been a former asteroid, which has been captured by Mars many years ago. So, my idea is to build three habitats inside Deimos, each one 1,960 meter in a diameter for example 7,000 inhabitants. You can three habitats, and this is the main axis. On the one hand, the main axis of the moon and the main axis of the three habitats. So once again, first of all, the space station is docked to Deimos, and afterwards it is enlarged into an industrial facility. Then a central tunnel is digged into the long major axis. So you see here the industrial plant and the facilities for docking. Here is a radiator for surplus heat, which may be used later. Here is the central tunnel, and here you can see the first rotating habitat. It is a rotating torus, and the width of the torus tube is about 160 meters. And I have drafted a section through this torus. Each torus is rotating about one round per minute and provides approximately 1 g artificial gravity or simulated gravity. The structure is driven by a magnetic levitation rail system, which you can see here in the section. And you see in the cross section how it is built. You have artificial lighting, which is provided by which is provided with nuclear power because we are very distant from the sun. The torus structure is made of inflated elements. It has a span of 160 meters. And then you see levels. One level is the housing level and the landscape level. And the other level is the agricultural level. And here on the ground is, of course, aquaculture and water and waste recycling elements. So the moon Deimos is supposed to be a carbonaceous body with a metal core. Water and oxygen is extracted from the polar ice of Mars, and the electric energy, as I said before, and artificial lighting is provided by nuclear reactors because of the long distance from the sun. Then the specification of one torus, about 7,000 inhabitants. And here you can see the housing area, landscape area, agricultural area, and so on, food production and so on. And of course, the volume of the air is, of course, very great, very big. Yes, and if you add the 7,000 inhabitants of one torus, the inhabitants of all of the three torus are here. 21,000, maybe a little bit more, or okay, something like this. So this was a small overview of my new project.
Quite interesting.
Cool.
Yeah.
Very interesting.
Yeah,
One
very interesting. Um, you can actually build something a bit smaller on the moon using the same idea
On the moon, yeah.
and have the same type and have the same benefits from it. And the advantage of building it on the moon is we already know how to do the construction because it wouldn't be much different than doing subway construction on Earth. I know that's something I was working on with the civil engineer about a few years ago before he died, is creating the 1G lunar habitats. And you want to start out smaller so you can build them, but eventually you'll build up the large ones like you have.
Mm-hmm.
And the key is nuclear. Nuclear
Yes,
power is needed
yes,
to keep the rotation going. The other thing
yes.
is going to be the transfer between the people in the torus and the people that aren't moving. And there's
Mm-hmm.
ways to do that, fairly simple ways. But yeah, that's why surface like the moon and Mars don't worry me on the low gravity because it's easy enough to build 1G structures there.
Is it possible, really? Okay.
Well, yeah,
It would be.
we have some time to talk to you, but it's much easier. Think of for the moon.
It would
Envision
be
this.
interesting for me how
Mhm.
it would look like.
Well, think about the moon. Think about a subway tunnel,
Mm,
roughly 3 kilometers in diameter.
yeah.
And the initial one would be 40 meters by 40-meter spheres that you speed up to around 220 kilometers. You angle them at they're fairly high angle because you want to use the 16.16 gravity of the moon and just add 8.84 to get the 1G.
Okay, I
But
think it would be inside the moon,
it would be under the surface of the moon.
under the surface of the moon, inside the moon. Yes.
Yeah,
Okay, I
you
see.
dig a trench
Yeah,
roughly 50 meters deep and 50 meters
yeah,
wide to put
yeah,
it in.
yeah, yeah. Okay.
And we know how to dig trenches. That's fairly straightforward.
I see. Yeah, yeah.
And then you use a nuclear reactor so you can keep it going. And after you want 2 nuclear reactors for redundancy.
And what is the radius of this
The one I'm using,
construction?
the one I'm using is roughly 2 kilometers, so you could do 1 point about 1.5 RPMs
Oh,
on
that's
it.
interesting. That's interesting. Yeah. Okay. Okay.
Yeah, we have time. We could talk about it because, like I said, this is something I've been working on for about the last decade. My friend started the project with me. He died back in 2018, but I've continued to work
Sorry.
on it.
Yeah.
But the advantage of it is that there's no showstoppers. It's just straightforward civil engineering, and you can do all the R&D work on the Earth before you ever build the first one there. Because of course, you just dig a similar tunnel on the Earth and just experiment with it.
Yes, maybe you can send me some sketches or
I'll
something like this so that I can prove
I'll
it.
send you. I can share with the group the PowerPoint I did
Yes,
at the Space Development Conference back in 2019, 2018 on it.
I see. Yeah. Yeah.
Okay.
Okay.
But yeah, it's a lot easier to build these 1G habitats on a surface than it is in open space because you have a construction platform to work on. Trying to get a torus or that perfectly square in open space is going to be a nightmare in terms of the specs you have to meet. It's going to be wanting to twist.
Yes,
And
and what you have in my project is you have much a shelter
mhm,
against rays and
yep,
against the micrometeorites and so on.
right. You have a huge amount of shielding. So you don't have to
Yes, a
worry
huge shielding.
anymore.
Yeah.
You don't even have to worry about massive solar flares. I mean, if you put enough shielding, it'll survive just about any type of radiation,
Yeah.
Thomas,
which is the event.
Okay.
must ask you. You said that building a large torus, um, as you've described on the moon, would be much easier than building it in free space.
Because
But
you have a surface to work on. Now, if you want to build one in free space, the first thing you need to do is build a construction jig that's very strong out of lunar material. And then you can use the construction jig to build it and mass produce them. but you need to have some kind of solid
Yeah,
framework to
that's
put it on.
obvious.
Huh?
No, you're actually just like the ISS is built by joining modules together.
Right.
So a large torus would be built by taking the components and adding
Mm-hmm.
on. But
Right.
if you do it on the moon, you're doing the whole thing under 1/6 gravity.
Right, which
You're
makes it a lot
building
easier
the
to do
ring.
construction.
Are you going to build this ring horizontally
You
or
build
vertically?
modules. You build the modules. What you do is build a tunnel with the maglev tracks, and then you put modules in the maglev tracks. And the modules give you redundancy. That way, you don't have one structure where if something happens, the whole structure's at risk. Each
No,
module is
no, no.
independent.
Yeah, no, I'm not worried about that. Building the individual modules is no problem. But is your ring going to be vertical and rotate like that?
Horizontal.
It's going to be horizontal.
That way you
Okay.
could that way you're not, see, if you do it vertically, there's times you're going towards the moon and away from the moon.
Yeah,
If
I
you
know.
do it
No, no,
horizontal,
that's okay.
you,
You've explained it.
yeah.
That's all right. Werner, I have some questions for you. Um, yes, it does provide excellent radiation shielding, but your lighting is all going to be artificial. What about vitamin D for the inhabitants?
I think one can create artificial lighting which has also the same influence on the human body than natural lighting. I think this could be possible
Oh
in
Okay.
the
yeah, it's
future.
easy to
In the
do.
future,
Yeah, we know how to create that lighting now. It's used all the time.
Okay. The other thing is you said that water and oxygen will come from Mars. Um, so you need to launch that from the surface up to Deimos.
yes, 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 yes.
And you're
But
going to have to be doing that continuously.
unless you build it on Mars.
I think there will be some stations on Mars for mining and for scientific
No, no.
purposes.
No, think
And
about,
Yeah,
uh,
I'm sure. But the point is that the inhabitants are going to need a continuous supply of oxygen. You're going to have to keep taking that up there.
yes, maybe sometime space elevator will be
Aha.
made, and then it's possible because
Oh, yeah.
yeah.
no,
Okay.
no, think about if you build it on Mars itself horizontally. If you build it horizontally on Mars, then your resources are all there, and you don't have to rotate it as fast because you've already got the Mars point 38. So you only have to rotate enough to make
Oh,
up that point
Yes,
62
but I
difference.
doubt if this will function because you have a relatively high gravitation of Mars, and it will disturb the rotation forces.
No,
No?
no, think
Can
about it. The
calculate.
gravitational field is constant. It's just like you're doing a train.
Mhm.
It's just a question of energy.
Yes,
hey,
And nuclear
calculation.
power gives you all the energy you want.
if
Mhm.
you have this ring, which is flat, parallel to the surface of Mars, and it's rotating, presumably it's going to need to be supported all the way around because it's going to be pulled down by the Mars gravity. But
It'll
also,
be in a tunnel. Build it in a tunnel, and that takes care of your structural support.
Yes, but the humans are pulled down. I think
That's why you angle
the
it.
yeah, yeah, okay.
You angle. It's a very simple analysis, vector analysis. You've got point 38 gravity, so you angle the structure in such a way that the point 6 gravity
Mhm.
combined with the point
Okay, okay.
38 gravity
Uh,
gives a constant downward pull in the
Mhm.
one direction.
Okay, we are
I'm afraid
discussing.
I don't understand that.
Can we go back a little bit to
Yes.
the Werner concept? Because I have a couple of questions. Can you share again your slides?
Yes. Wait a minute.
Okay. Yeah, exactly this slide I wanted to see.
Yeah, okay.
So as I understood, tell me if I am right or wrong, you are rotating the torus inside
Rotating the torus inside and not the entire
not the entire
celestial body. Yes.
Okay. But yeah, even so, I think you could make the torus is a little bigger because you have space that you are not using.
Yes, you can make them bigger, of course.
And
Yeah.
the,
This is
the,
just
big,
a model of
the
what would
bigger
be
you make
possible.
it,
What would be possible? Yeah. Yeah.
the bigger you make it,
Yes.
the lower the rotation speed.
Yes.
And
Yes.
the
Yes.
lower the
Yes.
Coriolis
Yes.
effect. I think we could also consider to make the wall moon to rotate. Why not?
I think this. I think this could be a problem because it is. As I tell you, the bulk density of 1.47 gram per cubic centimeter. This is not very much. This is not very much. So
Oh,
I have the problem that it would be not very good for the celestial body if it
okay.
rotates.
Okay.
It rotates.
So this
Ba-
stop,
basically, it's a rubble pile. If you rotate it, it comes apart.
It comes apart very.
Yes.
Yes,
You
I
gotta
think
look at the
so.
so this
structural
is more
geology of it.
this thing is more similar to an asteroid than to
Yes, it is an asteroid, of course. It is
Yeah.
an asteroid which has been caught by Mars, I think 100 million years ago or something like this. It is an
But
asteroid.
could could we keep it together, putting how can I
Yeah,
say rings
uh,
rings around the body?
I
yes,
was
we
also
could make
thinking,
a net around this, of
Yes,
course.
a net, exactly.
Yes, this is possible. We could put a net around this.
yeah,
Yes.
because I was thinking it's too fragile because it's only 15 kilometers by 12.2 kilometers.
Yes.
And then if it's too thin, you will have a problem and it could, I don't know what would happen, but I don't trust it. Yeah.
Yes, this was also
No,
my
but
consideration, but
Yeah.
Mary, we
if
want
you
to
make
live
a
inside.
network around this, of course, this would be possible to
Yeah.
make it thinner.
Yeah.
We want to live inside, not outside.
Yeah.
Yeah.
Well,
The material has to stay safe around it.
actually, one of the things you wanted to do, if you wanted to make a cavern in there, I know this is controversy because a lot of people aren't familiar with what work that was done on Project Gnome with nuclear devices. So
Yes,
if you
these are
blow,
nuclear devices. You can
you
see
set,
here
you
it in
set,
orange.
no.
Yeah.
You set off a nuclear bomb that creates the cavern and it fuses the walls of the cavern. Now, the radiation only goes in a meter, so it's easy to scrape that off. But then you have a solid fused surface sphere in there that you can build.
Yeah,
That's what they found when they were doing Project Gnome over here in New Mexico. When I went to mining school, one of my engineers had worked on that, and he spent about the whole week lecturing on nuclear devices for excavation and mining. Very interesting.
Now, I think there would be the problem that it will make exploding the complete body if
No,
you make nuclear devices.
no,
Yeah.
that's where you would calculate the size of the device relative to the body.
Yeah.
Yes, of
So
course.
it's
Yeah,
big
of
enough
course.
that it creates the chamber you want while fusing the surface around the chamber, but not so big enough that it'll fracture the body.
Yes, but I would prefer mining it smoothly, and of course process the material I think that would be another possibility and another way to
However,
mine.
my suggestion is to develop a conceptual paper, avoiding too detailed solution.
Yeah.
You could develop a conceptual paper indicating possible variants.
Mm.
One is the toruses inside. Another one is to dig a big cavern and build habitat inside, and so on. Other variants could come up to the mind when we start to develop the concept. That I think that would be better because it will leave to researchers and students the possibility to be creative
Yeah.
on the concept.
Yes, I can do that.
Excellent. Well, a very nice job you are doing, Werner.
Oh, thanks a lot.
Many compliments.
Yeah.
Many compliments. Okay. Well, so I think we could start to prepare. I think we can help you, Werner, to prepare this paper, and sending when you have a first draft, we can send you comments and possible edit parts and so on, and to prepare this concept for our next dates at Corpus at the IAC, and not this year at IAC, but maybe next year.
Maybe next year, yes.
Yeah. So it's very, very good.
Maybe I can send you a first draft in the next week or something like this, because I have already begun a first draft. I have started a first draft.
Very good.
I send it to you.
Please, Marie-Louise, I was
I
waiting.
have a question. Did O'Neill reflect about the possibility which Thomas preferred to build a horizontal rotating system on the moon? There's no comment by O'Neill. Okay.
As the students pointed out in the answer to their question, that on any planetary surface you will lose the sun for 50% of the time.
Okay.
You have to provide the power for that.
But that's why you use nuclear power.
Mm-hmm.
Yeah, but you don't have to, though.
Yeah.
There's nothing wrong with nuclear power. Nuclear power
No,
is
I'm not
nice and
saying
safe.
that there is.
I know, but it
The
seems
point
somewhat
is the sun's power is there for free.
right. And so
Yes.
is the radiation from
Yeah,
it.
if we are close enough to the sun. But Jerry, you have to think that in Mars, the power sun is not so powerful.
No, not so much. But the
And if
fact
we
that we
go,
are now
if we go farther,
spacecraft,
if we go farther to Jupiter, to the moons, to Ganymede and the moons of Jupiter, so you have to forget the power of the sun.
well, no, we have already sent solar-powered spacecraft to Jupiter. Our solar panels
Yes,
have grown so much. I'm not saying that is the best way to do this, but
no, I mean it's not the same amount of energy when
I
you're
know.
far. So anyway, you have to consider nuclear power as a source. Anyway, and yes, it is important. The comment that was made, I don't remember, maybe by you, about vitamin D. But that will be a problem for Ganymedian and the Ceres people and so on. So it's maybe something is a requirement that we have to add to our study. Vitamin.
Well, when you're doing the study,
is a human.
You have to look at the light requirements, not just for humans, but for the plants.
Yeah, light.
What's the spectrum?
Spectrum.
The atmosphere. Yeah. The exact spectrum that you need, that because different plants actually work different on different spectrums. That's why when you're doing a control environment greenhouse, you have lights that only put out in the spectrum the plants will use.
Mm.
And they've already studies that are looking at how to do that. So it's just a problem with designing the lights and then having the electricity for them.
Yes,
So
it will
it's
depend on the wavelength of the light, of course, on the wavelength.
but it's just a straightforward engineering problem. We already know how to do it and what the answer is. It's just like, putting the atmosphere together. We know you need carbon and you need a certain percentage of nitrogen. Or probably you need oxygen to breathe, but then you need nitrogen is so that you don't make a flammable bomb,
Yes.
so that you moderate the oxygen. And it's just it's straightforward. We know the answers. It's just putting the specs in. So it's not a showstopper. It's just a requirement.
Yeah.
Exactly. Very good. So we spent 1 hour. If we have other comments or questions, please go ahead. Or otherwise, we can close.
Adriano, your earlier suggestion that we should study these two documents, and
Yes.
I went into a fair amount of detail in my email to you about them.
I've seen.
To have a session discussing the documents and as the first step before we work our way forward, I think that's a very good idea. I think that such a session would be very useful because there is so much that they went into in their two sessions in 1975 and 1976. So much background material, and obviously we don't want to spend time duplicating that. We want to move forward.
Yes. Refer.
When is the next session? Here, our meeting.
When is the next session? Good question. Let me see if we already scheduled or not. I will tell you. And Academy.
We have in April, we have a board meeting in April.
When? When is it?
I think on the 3rd of April, we have a board meeting, isn't it? Adriano?
No.
No?
The 1st of April, we have the transport mining industry.
Yes.
Orbital.
Yes, it's mine. Yeah. Yeah. Okay.
And we don't have any more scheduled meetings. I think I have to prepare the calendar for the next. Okay. Yeah. So.
Okay.
But yeah, I think it's interesting. I think all the committees should go ahead making part of brainstorming, a part of a study, deepening and projecting new papers and yeah, to take ahead our work. And I think that in general terms, we should concentrate more on the cislunar space and to give this as an indication also where we are going to talk at Corpus, at IAC, and so on. Because I think the situation, I don't want now to introduce again the discussion about the astropolitics, but I'm afraid there is a possibility to lose the moon focus in this period. And I believe Space Renaissance should work to keep this focus on the cislunar space, because it is the first step of expansion. and we cannot think that a mission to Mars can replace the first step of expansion. So, in my opinion, we should develop more the different scenarios and possibilities about cislunar space, the Lagrangian points, the lunar orbit, the Earth orbit, and all this kind of things. Also, we have to, in the next meeting of the transport mining industry, we have to retake the work on the orbital debris too,
Mhm.
and to try to bring it at the next level, and to see what is the status of the art in the world about that. And but I'm afraid that could be another losing focus, no? Because they are thinking about the orbiting the ISS and all these kind of things. So I think that they don't take care very much of Earth orbit. So I believe that we are on the side of humans, and what humans need to have a safe orbit to work in industrialized orbit, industrialized cislunar space, and so on. So this is our mission, I think. Well, I'm already thinking also in terms of the thesis for the next World Congress. So all is together, the work of the committees and the work of the board and so on. We try to have a better synergistic work and the construction of our position.
Of course, cislunar orbit is the first step we have to approach.
But even
It's no question.
Okay, don't take me wrong. I mean, your work on the Mars orbit is very important, I think.
Yeah,
because we can show
can show it.
Maybe there are other possibilities
Yeah,
than making a city on Mars. No,
yeah.
we can show this and to start thinking about Mars as a logistic pole.
Yes, this was my idea.
Yeah, between the internal system and external one. So, I try to elaborate concepts and to go ahead. Okay.
When is it on April 1st and on which time? In which time?
April the 1st.
That's a joke.
April the 1st.
The fish in Italy is the fish.
On Fool's Day.
The people make jokes.
An April joke. Yeah.
Yes. Okay. Well, so always the same.
When is it? When is it? On which?
I think at 9 o'clock. I think at 9 o'clock, because every time of Central European time, of course.
Okay.
Central European time.
Okay.
Because I have to come back then. Okay.
Adriano, as something to look forward for a future activity. World Space Week, which is 4th to the 10th of October every year. This year, the theme is living in space. So it would be an ideal opportunity for the SRI to do something about these habitats.
Yes. Good idea. Yes, but forgive me, I never took care to understand how it works, the space week. So are there virtual meetings? Are there conferences?
Okay, it is a worldwide activity running from the anniversary of Sputnik 1, 4th of October, to the anniversary of the UN Treaty on the Peaceful Uses of Outer Space, October the 10th, 1967. And there are, well, in the UK, the coordinating body is the British Interplanetary Society. And something I do for them every year is I create a word search based on the theme for that year. But all kinds of people can independently organize their own events and activities, and if they register them with their country's coordinating body, they'll get put on a global map and list saying what's going on. So the SRI can say, yes, we are planning this seminar or whatever.
Yeah. Okay. Okay. Let's work on that. Thank you very much.
Along with that lines, just so I know it's not covered much in the media, but this is the 60th anniversary of the first spacewalk.
Well, yes,
60 years ago today. 60 years ago today.
Alexei Leonov.
Yep.
Yeah.
But you don't see much about that in the news.
No.
Although that is a milestone.
Oh, definitely.
Yeah. Okay. Take note of all these dates and see what. Yeah. Also, we have the Apollo-Soyuz anniversary.
Yes.
Yeah. Okay. Thank you very much, dear friends. See you next time.
Just before.
One more thing.
There we go. Right. I was in America in the Apollo launch 50 years ago for that.
Okay.
I've mentioned my Island Zero paper, which I've submitted for this event in Moscow at the end of April. They contacted me a couple of days ago to say that tomorrow they want to talk with me on Zoom to discuss it. So it looks like they're looking at it quite favorably. So I'll let you know how that goes.
Good. Excellent. Okay.
I wish you good luck and all the best, Jerry.
Yes.
Thank you. Oh, and
Yes.
Werner, I came across this email from you in which you said that because of your background, you would be happy to work with me on the development of the Island Zero design.
Okay, yes.
More detail. I'd certainly like to do that. We need to get together sometime.
Okay.
Of course. Well, very good.
Okay.
Thank you very much, everybody.
Okay.
See
Bye.
you next time.
Okay, bye-bye.
Bye.
Take care.
Bye-bye.
Take care.
Bye-bye.